Back to our next lesson on two-way tables. Today we're going to learn how to identify marginal and conditional distributions in a two-way table. A marginal distribution describes the overall distribution of a single variable by using either the row or the column totals. A conditional distribution describes the distribution of one variable within a specific category of another variable. Understanding the difference between these two distributions can help us to compare groups and interpret relationships within the data. So we're going to take a look at the difference between marginal and conditional distributions in this lesson. There's a lot less math in this lesson. So what I've done is I've written out the steps beforehand so that we can look at what these steps are for a lot of these problems. And it's going to be covering histograms and two-way tables for some of these. Some other problems are going to just be examining two-way tables and figuring out what parts of the data they want us to look at. So here's our first example on marginal and conditional distributions. So we have some information about Spirit Week at Alec's school. Students have these options of dressing up according to a different theme. On Tuesday of the Spirit Week, Alec recorded the number of students at his school by class and the style of dress. And so we have if whether or not they were dressed for Spirit Week or they dressed normally. And we also have the totals here based on the different classes. So we have freshman, sophomore, junior, and senior. And we want to know which graph or the graph of which distribution is shown below. So they show us this graph here, and we have to figure out which answer choice matches the graph given the graph and the table information. And so I wrote some general steps for us here. Step one is determine what the whole is. So we have to ask ourselves, what does 100% actually represent here? And if we look here at the bottom of our bar graph, I think I might have said histogram earlier. If we look at the bottom of our bar graph, we have dressed for Spirit Week as the label for the x-axis. And that's telling us that this is 100% of the students is students who were dressed for Spirit Week. And so this value, 696, is in the column for the total for the students who are dressed in Spirit Week for Spirit Week. So we're going to write 100% equals 696. So that's our first step there. Okay, our next step is determine the variable that's being distributed. So we want to look at the categories that make up the different percentages. So if we look back at this column again, dressed for Spirit Week, it looks like we have a total, and then we have 1, 2, 3, 4 categories. And we also have 1, 2, 3, 4 categories on our bar graph. So you have freshman, sophomore, junior, and senior. So the class is what the variable being distributed is. So it's either freshman, sophomore, junior, senior. Okay, now we want to figure out whether the distribution is a marginal or a conditional distribution. So if it's a marginal distribution, the whole, the 100% part is the entire sample, or we can think of it as the grand total. If it's conditional, it's on the condition of one of these things happening. In this case, whether they're dressed for Spirit Week or whether they are dressed normally. And so this one is not looking at a grand total. 100% is on the condition of that the students are dressed for Spirit Week. And so this is a conditional distribution. So the whole 100% is one column in this case. It's not the grand total. I'm just going to write that here. Not the grand total. All right, and now we want to state the distribution. We want to figure out the variable being distributed, and if it's conditional, the group that it's conditioned on. And so this graph shows the conditional distribution of students who are addressed for Spirit Week. So we're just combining steps 1 and 3 and putting this into a sentence. So if we look at our answer choices, this is answer choice A. It's the conditional distribution of students who are dressed for Spirit Week. So it's on the condition that the students are dressed for Spirit Week, and that would equal the 100%. Okay, let's look at another one of these. I wrote our steps out here again so we can look at this. We also have Spirit Week again. It looks like this is the exact same data from before. Let's just double check here. Yeah, it's on a Tuesday of Spirit Week. This one's on a Tuesday of Spirit Week, and we have the same numbers in our two-way table. And the question here says, what's the best description of the boxed information in the second row of the table? So this is our first row, just the words, and this is our second row of our table. So it wants to know what's the best way we can describe that. So again, we'll go through these steps. What 100% represents in this case is 248 freshmen. So it's not the grand total, it's just the 248 freshmen. For step 2, we determine the variable that's being distributed or determine the categories that make up these percentages. And again, we have, are they dressed for Spirit Week or are they not, or are they dressed normally? This one's dressed normally. Okay, so if they're dressed for Spirit Week, we have 175 students that were dressed for Spirit Week and 73 that were dressed normally. And now this one's going to be a conditional distribution for step 3. The whole that we were referring to from step 1 is not the grand total. So I'm just going to write that the 100% does not represent the grand total. Okay. And now we want to figure out what the distribution is, or how are we going to say this? This is a conditional distribution for the freshmen that are dressed for Spirit Week. So we're combining all these steps, 1, 2, and 3 to get our final answer for 4. This is the conditional distribution for the freshmen who are dressed for Spirit Week. Or, excuse me, dressed for Spirit Week or dressed normally. We're looking at both of these, not just dressed for Spirit Week. So this is answer choice D. Because for part 2, we've written down both of these variables that are being distributed, and we're looking at both of those because those are both boxed in there. So this one's answer choice D. All right, let's take a look at marginal distributions next. So a marginal distribution describes the overall distribution of a single categorical variable by using the row or the column totals. And because a marginal distribution represents the entire sample, it allows us to see how the data is distributed across one variable without considering the other. So here we have a table giving the thousands of commuters in Alabama in the year 2015. And we're looking at transportation methods and the time that it took them to commute to work just one way. So just getting to work. That's what the commute duration one way represents. So we have all this data, and it wants us to find the marginal distribution of the one-way duration of a commute in percentages. And so this first step says identify the variable being distributed. The variable that's being distributed is, let me just highlight this here. So the variable being distributed is the one-way duration of a commute. And another way to say that is it's just the time. The duration is time. So we're measuring time. That's the variable that's being distributed. Step two, we want to locate the totals for that variable. So we're gonna just look at all the individual totals for less than 15 minutes to get to work, 15 to 25 minutes to get to work, and so on. I'm just going to write row totals to save us some time. Okay, we're going to use the grand total as the denominator. That's our grand total in the bottom right. We have total and total to give us our grand total of 1,938. And now it says to find this in the nearest percent. So we're looking at our row totals. We know that we're looking at those because each of these answers that it wants us to find is a row. So that's a row. These are all rows. And so that's how we know that we're going to use these total values for each row as our numerator, or our row totals for our numerator. So for less than 15 minutes, our numerator is 526 and our denominator is 1,938. And we're going to follow that same pattern for all of this data. So for 15 to 29 minutes, let me just put this back in black here, is 758 over 1938. 30 to 44 minutes is 393, 1938. 45 to 59 minutes is 146 over 1,938. And then our last one, I'm just going to scoot the page down a little bit, is greater than or equal to 60 minutes or more. We're saying 60 minutes or more to commute to work. So that's looks like 115 over 1,938. Okay, now we're going to convert these to a percent. It wants us to convert this to the nearest whole percent. And this part's pretty simple. I'm just going to show you what I got when I rounded these. This is 27%. This is 39%. This one's 20%. And again, we're just dividing on the calculator and then multiplying by 100 to get our percent. Okay, and that's our final answer for this. So just identifying that we're looking at the row totals and we're using our grand total as our denominator for this marginal distribution is the key idea for this one. So we're looking at the margins or the edge of the table data for these. Let's look at one more and then we'll jump to conditional distributions. So this person is looking at weather conditions and they want to know whether the train downtown is going to be on time or not. So it's either the train's going to be on time or it's going to be late or delayed, is another way we could say it. And we have these different weather conditions that we're looking at. That we're given all of these results in this table here. And we want to find the marginal distribution of arrival status in counts. And so in counts, that means that we don't want a fraction or a percentage. We just want to know what the number is that we're looking for. And so for step one, the variable that's being distributed is, it says find the marginal distribution of arrival status. So that's the variable that's being distributed, arrival status. And the arrival status is either on time or delayed. And we can see that in the answer choices that it wants us to enter in there. So we're going to look at the totals for each variable. I'm going to highlight the entire columns just so we can see them a little bit easier maybe. So locate the totals for that variable for on time. Our total was 330 trains that were on time, and the trains that were late or delayed is 35. And then we don't need to do 3 or 4 because it just wants to know in counts, what's the number? So what's the number of on-time trains? 330. And what's the number of delayed ones? 35. So we're just looking at the marginal total there. If we wanted to find a percent, we could. So if it was asking us for a percent, let's take this one step further. So the grand total is 365, and then we could figure out, well, for on-time trains, this is 330 out of 365, and for delayed trains would be 35 out of 365. And then we just convert that to a percent, whatever that is. But this is asking for counts. So counts, that's just our counting numbers. Okay. So no fractions, no percents. All right, that one wasn't so bad. Conditional distributions are next. So a conditional distribution, it describes the distribution of one variable within a specific group or under a certain condition. To find these distributions, we compare each count to a row or column total rather than the grand total. And we looked at this, I think, earlier in one of the other examples in the beginning. But now we're just looking at a row total, or we're looking at a column total for these. And we needed to figure out what that is exactly. Now, I didn't put steps for the conditional distributions this time because we have some answer choices where it says choose all that apply. And I thought it would be easier to just go through A, B, and C and see which one or which ones were true based on the statements that they give us. So it looks like we have this data um, based on geographic region, and it's how many Democrats, Republicans, or independents that there are based on each of the regions. And so we want to figure out which of these interpretations is correct. So for each of these statements, we're going to read the statement carefully, identify the condition, and identify what the statement is claiming. So that's our first step. I'm just going to write our first step is just read each statement and identify the condition. Okay. So let's look at letter A. It says, given that a senator was in the Republican Party, I'm going to try to color code some of this. So, given that they were in the Republican Party, the senator was more likely to represent the Midwest than any other region. So, I'm going to highlight all of the Republicans. So now we know we're looking at um, a column. So, this is under the condition that someone is a Republican. So, that's the same thing as saying, given that they're in the Republican Party. Another way you can say it is a condition, on condition that. So the senator was more likely to represent the Midwest than any other region on the condition that they were Republican. So let's take a look now. So the Midwest, um, there's 11 out of 55 Republicans. So right, this for A, Midwest is 11 out of 55 Republicans. And it says any other region. Well, so it's basically saying that this is the most in the Midwest. Well, it looks like we have 20 Republicans in the Southeast. So that one is the most. So there's 20 out of 55 Republicans in the Southeast. So A is false because there's more in the Southeast. say more in the Southeast, more Republicans in the Southeast. Okay, so A is false. For B, it says, given that a senator is an independent, it is certain that the senator represented the Northeast. So on the condition of the senator being independent, so we're going to find the independence column, highlight all of that. It says it is certain that the senator is from the Northeast, or the senator that's being represented is from the Northeast. We just have one senator who's an independent, and they are from the Northeast, and so B is true. Okay, and let's check C because it says choose all that apply. So for C, it says given that a senator represents the Southeast. So now here's our new given statement that a senator, or conditional statement, represents the Southeast. It's likely that the senator is in the Republican Party. So we're going to take a look now at this row of the Southeast, and we're going to see if that statement's true. It looks like we have 20 Republicans from the Southeast and 6 Democrats from the Southeast. So yeah, we could say it is likely that the senator is in the Republican Party. If we wanted to be more exact, we could say that the likelihood of a senator being in the Republican Party is 20 out of 26 for Republican in the Southeast, and 6 out of 26 that the likelihood that they are a Democrat from the Southeast. Okay, so this one's true also. It's more likely that they are Republican, and we just so happen to have that same 20 there that we're using for this one. Okay, so B and C are both true for this problem. Okay, we're going to look at just a couple more of the conditional distribution problems. Here we have a survey of 11th grade students at a school. And somebody wants to know, Laura wants to know about the languages that they speak and whether or not they have allergies. So she's trying to find a correlation, it looks like. But we want to find the conditional distribution of whether or not the person has allergies for the students who speak 2 languages. So we have allergies, no allergies, and then number of languages. So our first statement, we want to identify the condition, identify the conditional statement. And the condition is that the students speak 2 languages. So I'm just going to write identify the condition. So the students speak 2 languages is our condition. So let's highlight that row. That'll be the condition that they speak 2 languages. Okay. So now we're going to figure out the the distribution in terms of percentages of this. So our total that we are using is going to be 33 students. And so now we're going to write out our percentage. Oh, well, first we'll figure out what it is as a fraction and then convert to a percentage. So just say write as a fraction. And so for a student who speaks 2 languages and has allergies, that is 19 out of 33. And students who have no allergies, that's 14 out of 33. Okay, and then we're just going to convert that to a percentage. It says to round to the nearest 1/10 of a percent. So when I did this on the calculator, I got 0.5757, and that's 57.57%. And if we round that to the nearest tenth, that's 57.6%. For no allergies, we do 14 divided by 33, we get 0.4242, which is 42.42%. And if we round that to the nearest tenth, we get 42.4%. Okay, so again, our condition was that they speak two languages. We found the total of that condition, and then we were able to determine um, the the percentages of whether they had allergies or no allergies based on the table data. Okay, we're going to look at one more now with table data and bar graphs. So this is on people who were on the Titanic many years ago, and it's table data based on whether the people lived or if they did not survive. And so there's a different classes of people. So people who bought a first class ticket, second class ticket, third class ticket, and then the crew, the people who are working on the ship. And we have information of if they survived or if they died. And then we also have our totals. So these are conditional distributions. So our distribution questions. So our first step is we want to figure out what the condition is. So we're going to identify the condition. Okay. So it says which graph displays the conditional distribution of whether a person survived or died. Let me see the color here. Whether a person survived or died for the crew. Okay. So that means we're looking at our condition is that they were on the crew. So that's going to be our row that we're going to focus on is the crew class row. So our total of our conditional total is going to be 913 people. Okay. And now we're going to determine the fractions and percentages of these values. And then percentages of the values of the condition. So if the crew survived, it looks like we have 215 people who survived out of 913. If the crew died, then we have 698 out of 913 people. Okay, we're going to convert these to a percent. So if they survived, that's about 23.5%. And if they died, that's 76.5%. And I think I did some estimations there, if I remember correctly. Okay, so now we're going to look at the bar graphs for these. So we have crew survived 23.5%. This A looks like we have, well, let's look at the one that's easier to read. It looks like this one's easier to read. This is uh, less than 80%, but definitely more than 70%. So I'm going to go with the crew died is the darker blue, and that's 76.5. That's close to 76.5. And then 23.5 would be this smaller one. Now, if we look at the other one, it looks like we have the people who died. This is in the 20-ish percent, maybe about 23.5 again, and we'd put our numbers like that. Now we just had to figure out which graph matches. And the crew that survived was the smaller number, and we've got the smaller number of crew survived is on A. Okay. All right. Finally, we're going to look at interpreting two-way tables. We're going to look at a couple of questions where we're going to see it's going to appear like we've found the right answer, but we have to double check to make sure that our frequencies or each row or column adds to 100%. So instead of finding just one value, we're going to carefully read each claim, identify what part of the table that it refers to, and then we'll determine whether the statement is true or false. We'll look at answer choice A first. It says 57% of the students in this sample do not own a cell phone and did not bring a personal device. When we first look at this, we can see the intersection is 0.57, which appears to be 57% of the students. But this problem specifically states in the sample. In the sample means everything. It means that we're looking at a grand total. So I'm just going to write in the sample. That would refer to our grand total. But we aren't comparing the grand total for this. We're only looking at the row here, and the row totals up to 100%. But we want to look at both of these rows, and so we don't have enough information to conclude that that's 57% for this sample. So A is incorrect. For answer choice B, this says a student who owns a cell phone is less likely to have brought a personal device than a student who does not own a cell phone. So now we're looking at bringing a personal device, and uh, we're comparing does not own a cell phone or owns a cell phone. And so it says that the student is less likely to have brought a personal device uh, who owns a cell phone. So owns a cell phone is less likely to have brought a device than does own a cell phone. And that would be saying that owns a cell phone 0.80 is less than 0.43. And that's false. That is not true. So B is false. I'm going to cross that out. And for C, it says a student who owns a cell phone is more likely to have brought a personal device than not to have brought one. So now we're looking at this column here. A student who owns a cell phone is more likely to have brought a personal device than not have brought one. So brought a personal device is 0.80 is greater than bringing a device 0.20. And that's a true statement. That is true. Just to be consistent, let's check what D is here. So for D, it says a student who did not bring a personal device is more likely to not have a cell phone than to have one. Okay, so now we're going to look at this column for D. We're going to look at a student who did not bring a device is more likely to not have a cell phone than to have one. So not have a cell phone more likely than to have a cell phone is the statement that it's telling us. Um, so 0.57 greater than 0.20. That's true. That's a true statement. But we're the same thing as in letter B, we're we're not able to compare this because this does not equal 100% when we're looking at the columns. We're only able to conclude that it's 100% from the rows. So we cannot say that this is true. This is false. Even though 0.57 is greater than 0.20, that column does not add up to 100%. Okay, let's take a look at just one more of these two-way table problems. I think these are tough because they're reading problems. There's a lot to read through and check on these. This next two-way table is a column relative frequency table, so it's different than the last one. We're now able to add up our columns of the frequencies, and those columns should equal 100%. So again, we're going to look through all of our answer choices and try to decide what those are. if they're true. Only one of these is true. So we have this two-way frequency table on role models that people have versus their level of education. So we have their education level less than high school, some college, bachelor's degree, and advanced degree. And then their role model is either a family member, friend or acquaintance, or a complete stranger. And then based on this data, we want to know which of the following statements have to be true of the people that were surveyed. So if we look at answer choice A, it says a person whose role model is a family member is less likely to have an advanced degree than a person whose role model is a friend or acquaintance. So let's write that out of what it's saying. So it says a person whose role model is a family member is less likely to have an advanced degree than someone who's a friend or acquaintance. Okay. And um, this is just looking at the entire column. So we're looking at family members or acquaintances, and we're also looking at the advanced degrees. So now we're going to look at the advanced degrees section. So that's here and here. And it looks like the family member is 0.14, and for the friend or acquaintance is 0.12. And so that is a false statement. That is not true. We can compare these two values because we're looking at the columns here, and the columns add up to 100% for both of those columns. Okay, for letter B, it says a person whose role model is a stranger is more likely to have high school than some college as their highest level of education. So now we're going to look at the stranger column. And we're just looking at the stranger column. We know that that column all adds up to 100%, and we're comparing two values that add up to 100% here. So the stranger column is for high school is 0.40, and some college is 0.23. Now, I forgot to write out our original statement. So it says a person whose role model is a stranger is more likely to have high school. So we're going to say high school is greater than some college. Okay. Um, as their highest level of education based on that it's their role model is a stranger. So for high school is 0.40, it's greater than 0.23. And that's a true statement. These add up to 100%. And so we can conclude that that's true. Now let's just check C and D just in case. And I think it's always good to see examples that are counter examples so that we can continue to refine what we already know. So letter C says a person whose highest level of education is a bachelor's degree is more likely to have a family member than a stranger as a role model. So we're going to look at bachelor's degree now. And just by looking at the condition of them having a bachelor's degree, we're now going to say that they're more likely to have a family member than a stranger as a role model. So family member greater than stranger. So we're just looking at this column, 0.23, and this is stranger 0.14. Okay, so we have 0.23 is greater than 0.14. And that looks like it's a true statement. But if we're looking at the bachelor's degree row, this row does not add up to 100%. So this row does not add up to 100% because this is a column relative frequency table. So C is false also. And I'm just going to circle B because we know that that's our answer. So C is false. Let's look at D and see if we can see another counterexample. So a person whose highest level of education is less than high school is more likely to have a stranger than a friend or acquaintance as a role model. So now we're looking at less than high school. And our statement is they are more likely to have a stranger. Stranger is greater than a friend or acquaintance as a role model. So we're just looking at this row. The stranger is 0.19, greater than a friend or acquaintance, 0.12. That looks like it's true. But again, we're looking at a row, and our row does not total to 100%. So same thing as what happened with letter C, is that the row does not add up to 100%. So we really have to keep that in mind when we're looking at these frequencies. If is this a row or a column table? So D is false as well. All right, so that is everything on distribution of two-way tables and looking at marginal and conditional distributions.